Okay, so my name is Yousef Abuabdou, and my project is what type of water do flocculants clean best? The purpose of this experiment was to know how the water we are drinking was once brown and muddy. You might be thinking that this water is naturally clean and comes from a mountain spring that has no dirt. This is not true. All water has some dirt to some extent. All water has had some type of dirt, debris, or other contaminants such as bacteria. This happens because water travels and it is almost impossible for it to not contract some type of substance that is bad for us or dirty. In this experiment, I'll be trying to find out whether flocculants clean lake water, river water, or pond water best. Some facts about this project is that flocculation is a process by which colloidal particles come out of suspension to sediment under the form of flock or flake, either substantially or due to the addition of a clarifying agent. Most American homes are supplied from water sources such as lakes and rivers. These muddy waters, once consumed by humans, can cause many diseases such as salmonella, cholera, E. coli, and hepatitis A because of the bacteria it carries. Colloids are particles that are too light to sink to the bottom of the water, so they float, and that's what makes the water look dirtier and muddier. This flocculation solution doesn't purify the water, it only clarifies it. To purify the water, you need to skim and filtrate it. This will make the water drinkable. Flocculation will make all the particles sink to the bottom, so the water will look cleaner and be easier to purify. The problem question of this experiment is what water gets best cleaned by optimal flocculant concentration. My hypothesis is that the lake water will clean up best because the water is controlled by a dam and it is man-made. The pond water is usually routed to the river and the water comes from the same source. When looking at the water, the lake water already looks cleaner. The pond will be the dirtiest because it is the smallest body of water of the three, so the mud or dirt in the water will be more in terms of the ratio to the water. The independent variable of this project is the location of where the water comes from because it changes. The dependent variable is the turbidity of the water, and that's what I'll be measuring. The control variable is the tap water. That is what we're trying to get the three waters closest to. The constant variable is the alum solution or the flocculant solution. So for the materials, you're going to need 2 cups of lake water, 2 cups of river water, 2 cups of pond water, alum powder, which you can buy at the grocery store, a measuring cup to measure the water and the alum powder, soil, an object for mixing, and 4 clear containers. And if you want, you can have a Sharpie to differentiate between the waters. The first thing you're going to need to do is go to each body of water and have a measuring cup to get 2 cups of each type of water. Get 1.5 spoons of the soil or mud and mix it into the waters as wholes. Get warm tap water and put about 1.5 cups of it. Mix 3 spoons of the alum powder with the tap water. Put about 1/3 cup of the alum solution in each cup of water. Mix another spoon of alum powder into each cup. Stir for 2 minutes and then let the water sit for 10 to 15 minutes so that all the colloids can sink to the bottom. Measure the turbidity of the water by comparing it to the tap water. Here are some pictures of me doing the project. So in this chart, there was only 2 trials because the trials take a long time. So there was 2 trials was a little bit more efficient. So for the lake water, we had 3 out of 10 for the trial 1 and trial 2. So the average was 3. The pond water, trial 1 had 2 and trial 2 had 1. So the average is 1.5. The river water is the first one got 5, the second one got 3, so the average is 4. This is a comparison. These are all measured based on comparison to the tap water of 1 out of 10. Here's a column chart, and here's a bar chart, just in case you want to look at one of those. So according to the results, the river water had the cleanest water. This proves that the hypothesis was correct and incorrect at the same time. The hypothesis had two parts to it. One part states that the lake water will clean up the best, which was incorrect, as the river water cleaned up best. The second part states that the pond water will clean up worst, meaning it will be the dirtiest, and that was correct. So in conclusion, this project was a success. Although the hypothesis wasn't completely correct, it still taught the researcher something and is useful for our everyday lives. This not only helps us with purifying water in a cheap way, but in a fast and efficient way. What the researcher would like to do for this project in the future is be more specific with the measurements of the alum solution. The researcher would also like to use an electronic kit from home science tools. This will come with a turbidity meter, which is a more accurate way of measuring the turbidity of water. The second thing the researcher would like to do is not only use flocculant solution, but to also purify it and filtrate the water. This would help humans in real life because it is much easier to filtrate and purify water once this is done to it. So for the bibliography, this is Science Buddies. This is where I got like the idea of doing this project.